Yes, ma'am.
Okay. If at all I get muted or anything, please let me know. All right. I think by mistake I muted myself. Okay. All right. So in the last class we had talked about different access mediums, physical as well as wireless access mediums. In this class we are going to look at the network core. Okay. So I am showing the same picture here as I have been showing for the past few lectures, because this is the picture that represents, we visualize the internet as such. Okay. So today we are going to look at these highlighted parts. All right. So these highlighted parts basically form the network core. They are either the regional ISP or global ISP. Okay. So what is this regional ISP and global ISP, that we will see in this chapter itself. But before that, for now, when we are talking about network core, we will just consider them as some routers which are connected with each other. Okay. Now, when we are talking about something that is worldwide, so you can only imagine how many routers will be there which are interconnected. So basically, this becomes a mesh of interconnected routers. Okay. So the backbone or the network core of internet is basically a mesh of interconnected routers. Okay. Now, how should we transfer data from one point to another point? That is, if I am talking about one router, routers being connected with each other, then how do I transfer data from one router to another in this network core? Okay. So we have already studied a little bit as to what is known as packets, right? So packet is nothing but a chunk of data, right? That is used to transmit the information. Okay. So packet switching is a technique where the host system basically breaks the data into different chunks of, breaks the message into different chunks of data. Okay. And that is known as packets. And then these packets are transferred over the medium to the destination. That is known as packet switching. Okay. I hope I'm clear in this. I will again um, clarify in the next slides. So basically what will happen, that in the network, these packets will be forwarded from one router to another router. Okay. Through these links which are there in between them. Okay. So each router can act as a source and the other router can act as a destination, depending upon who is transferring the packet. Okay. Now, when we are talking about the network core, what are the functions that are there, or that the network core provides? What are the functions that the network core provides? So there are two key network core functions. One is known as routing, and another is known as the forwarding. Okay. So what's happening here? Now, please look at this router. Okay. If you are unable to see my mouse, please let me know. Mouse pointer. So here, just take a look at the router which has been highlighted. So from you can see that in the router there are packets which are arriving. Okay, and see, this is the packet, and in the packet's head it is written 0111. Okay, so that is, let us assume that that is giving the destination address of where the packet should be transferred to. That means if you are sending, suppose, a letter, so just assume that a packet is like a letter. Okay, so if you want to send a letter from your house to your friend's house, what do? You basically post it, and when you post it, what do? You put the um, address to which the letter has to be sent, and your own address. So there is a to and a from. Okay. So when we are sending packets over the network, there also we need to have a to and a from, right? So the to is the destination and the from is the source. Okay. So the destination address is given here in this packet. Okay. Now, only after seeing this destination address, this router, okay, look at this router. This router has so many outgoing ports, right? So only after looking at this destination address, the router can make a decision as to which port this packet needs to be forwarded to. Okay, so there are two decisions that need to be made here. One is that uh, depending upon this destination that has been given in the packet's header, what is the path towards the ultimate destination. So suppose um, let us suppose that this guy is the ultimate destination, the one in the last. Okay, now if you have to transfer your packet to this last destination, the next decision that needs to be made at the router is that if the last destination is this guy, in that case, which port should the packet be forwarded to right now? Okay, right now, which port the packet should be forwarded to? So now the choices are between port numbers 1, 2, and 3. Okay, so this router will then decide that, okay, among these three ports, which port should this packet be sent so that it reaches its ultimate destination. So after looking at the forwarding table that is there, so I will talk about what is forwarding table also. So after looking at certain calculations, this router basically decides that, okay, port 2 should be the one where the packet should be transferred, okay, so that it can reach its destination. So this decision that what is the ultimate destination and ultimate path through which the destination can be reached, that is known as routing. Okay, so basically the name itself says, right, you are finding the route to your destination. Okay, so in each router, see, look at this, there is a routing algorithm. The routing algorithm is basically telling as to what is the ultimate path, path to the ultimate destination. Okay, so the routing algorithm will decide that what path should be taken so that you reach your destination. Now you may ask me a question that, okay, why should I be bothered about this kind of a routing algorithm, this kind of a path? Because it seems that the network core itself is a connected graph. So there will be a path from one router to another in any case. So why should I be bothered about this? So the first thing is that when you are talking about the internet and giving the user some service, your main concern first comes that you have to maintain a particular delay in serving your user, right? So you always want everything to be faster, okay? And in order to have faster access, you need to reduce the delay that goes on in the back end, right? So here too, the routing algorithm, one of the tasks of the routing algorithm is to find out the best path that you can get in order to reach the destination of the packet. Okay. Now, given this information, suppose there are some few packets which are coming with these kind of addresses. Okay, 0100, 0101, like that. Okay. Now, after looking at the data that is coming and the result of the routing algorithm, it can be found out that, okay, if the packet is coming with this header, that means it will go to this particular destination. So the output link will be either 3 or 2 or 1. So see, if you send a chunk of data, okay, you are basically sending that basically that chunk is part of a bigger data. Okay, so we are basically dividing a message into small chunks. Okay, now these chunks are getting sent over the medium. So if a message is divided into some n number of packets, it will definitely have, so you are sending a message, right? So it will definitely have the same destination address. Okay, if you are dividing the same message for the destination. Okay, so there are n number of packets with that same destination. So once you get to know that, okay, first time when this packet arrives, and it has just a chunk of that entire message, you see the header, you find out what will be the destination, and then you get that information as to which port should it be forwarded to next. Now, when the next packet comes, same thing will happen, that okay, this is the same address, and therefore it has to be forwarded to the corresponding port. Now, you have to store this information somewhere, right? So that is known as the local forwarding table. Okay, so the local forwarding table basically stores this information, that okay, if this is the header value, that means if this is the destination address that you are looking for, then you have to move towards this particular output link. Okay, so this method of forwarding the packet to its corresponding output link at the router, that is known as forwarding. Okay, so forwarding is a local action. It is also known as switching. Okay, and routing is a global action. So as I already mentioned, it is basically just going to determine the source destination path that should be taken by the packet. Okay. All right. So here it has been given, like, just an example to show that what is the difference between routing and forwarding. So if you can see that, from San Jose to Northampton, you can see that this is the path. Okay, this is the, if you go by Google Map also, this is the path that will be shown. Okay, so this is known as routing. That is, you are finding the best route from one source to a destination point. Okay, now, yeah, okay, great. Let's go to this part. Okay, so now here it has been zoomed in a little. So San Jose to Sacramento, it is being shown. Okay, so you can see that from Sacramento, you can go to several places. Okay, and still you can reach to Northampton. All right, but which path should you take so that you will get the shortest time? Okay, so what is the next step in that shortest path that you should be taking so that you actually follow this shortest route? So that is known as forwarding. Okay, all right, the same example is given here too. Now, all right, okay, now let's get to the next part, which is what we had started with, that is packet switching. Okay, now we will get into details of what packet switching is. So the main thing that is in packet switching is you are sending data in the form of chunks known as packets. Okay, and these packets are being transferred over the medium from the source to the destination. Okay, so now it's like you had a very big file. You just divided that file into small parts, and you are sending these each of these parts independently over the medium. Okay, so if each one of these packets is of L bit size, and your link capacity is R bits per second, then your transmission delay will be given by L by R, which we have already studied in the last class. Okay, so let us see what is happening in packet switching and what is this term that is given out as store and forward. All right, so see, this is the packet. Okay, this is a big packet. The whole chunk is here. Okay, packet number one. All right, now when we are sending a packet, it is of size L bits, right? And transmission delay is L by R. Okay, so what is the transmission delay? Please remember the definition. Okay, transmission delay is the time taken to transmit a packet onto the link. Okay, link is this link. Where's mouse? Yeah, this is the link. Okay, so from your source system, if you want to send the packet over the link, so the delay that will be taken up is L by R, seconds. Okay, so only to put the data, so just you can imagine like you are just putting the chunk of the file onto the wire. Okay, uh, if it's a wired connection, of course. So I'm just giving you an example, please don't take me literally here. So you are just putting that chunk of data onto the medium. All right, so it is taking some time. That means what? It is not going instantaneously, the entire chunk of data, right? It is going part by part like this. You can see here. Okay. So what is this store and forward thing? So this is a router. Okay. In between this source and the destination, there is a router in between. So until the entire chunk of packet has reached, it will not be forwarded from this intermediate router. Okay, so this is what store and forwarding is. That means you keep storing the data until the packet is entirely received at a particular destination, and then you forward it further if it is required. Okay, so this packet, once it was transferred, see, there will be a transmission delay to put it on the medium, and of course, there are some other delays also, which we'll talk about. So it takes some time to send the entire L bits of data to the router, intermediate router. Okay, so this, the until this time, all the data which is already received, they have to wait until everybody, all the bits, all the L bits have reached this particular router. Okay, so that is known as store and forward. Okay, so this is a very prominent feature of packet switching. Okay, so if anybody asks you what is store and forward kind of switching, what is a very prominent feature of packet switching, okay, a good quality of packet switching, then that is store and forwarding. Okay. All right, so this is just an example that has been given with L is equal to 10 kb and R is equal to 100 Mbps. So what would be the transmission delay? So now one hop transmission delay is like you are just moving from source to the one router. Okay, that is just one hop. The next one will be two hop. Okay, the second hop basically. So if I say that what is the number of hops from source to destination, you can say that there will be a two hop delay. Okay, so one hop and then two hops. Okay, I have told about store and forward. Okay, now we know that if we are using packet switching, and there is a router here. Okay, one router is given here. Now, of course, the router is connected to, if it's a network backbone, if it's a network core, it will be connected to several devices, or even several routers also for that matter, right? Because it's an interconnected mesh of networks, right? So let us assume, for example, that there are these two devices A and B, and they are connected to this router. Okay, the link speed that is there from the uh, host A to the router is 100 Mbps, and also from the host B to the router is 100 Mbps. Okay, megabits per second. So now, as you can see that, see, if it is 100 Mbps, then the speed is quite high. All right. Now look at the speed from the router to another router. Okay. Look at the link capacity from one router to another router. That is 1.5 Mbps only. Okay. So you can see that how fast the data will come from the source and how slow it will go compared to that capacity from one router to another router. That is, the intermediate path is having very slow capacity, very low capacity as compared to the capacity from the host to the router. Okay, so that means what? when you are dividing a message into large number of packets, a large number of packets will just arrive at the router and they will wait until they get a chance to transmit to the medium, right? That is transmit to the path between these two routers. Okay. So what will happen? They will form a queue. All the packets which are coming to this particular router, they will form a queue of packets waiting for their chance to transmit over the output link. Okay. This concept is known as queuing. Okay, queuing at routers. So as has been given here, so this is similar to, these are some examples that have been given that why a queue forms. Okay, just similar to a queue of humans or a queue of vehicles in a traffic jam, like that. Okay, so similarly, you will form a queue of packets at the routers if there is a mismatch of capacities, like as it has been shown here. So what happens if there is a queue? Okay, what happens if I have a large number of packets coming to a router and they are forming a queue? Okay, so what will happen? They will simply wait for, you will say that, okay, they will wait for their transmission to the output link, and when they get a chance, they will get transmitted. But remember that, when you are sending some data, it has a lifetime, right? So you can only suppose, let me give you an example. Okay, so I work in vehicular networks. So it's basically autonomous vehicles. So let me give an example from there. So suppose I have, like, some car which has partly autonomous vehicle characteristics. Okay, so now I am going through a road and it has a hairpin bend, and I cannot see who's coming from the other side. But the person who's driving from the other side is basically drunk and he has been doing rash driving. Okay. So once somebody is doing rash driving, the cameras on the road, they basically pick up this information that this particular car is not having a stable driver. Okay. So now I am also moving with suppose around 80 to 90 kilometers per hour speed, and the other guy is of course going beyond 120. All right. So in that case, what would happen? This information needs to be sent very fast to me. Otherwise, definitely it is going to be a very life critical situation. So the packet that is being transmitted, so this information of course will be transmitted via packets, okay, in the form of packets. So this packet that is being transmitted, that has to be transmitted within a very small or very specific amount of time. Okay, so that is known as, so any packet which has uh, time constraint to be delivered, that will be considered as the lifetime of that packet. Okay, so the packet has to be transmitted very fast. All right, otherwise there is no need of that packet. If you send me the information after I have crashed and died, it really does not matter, right? So when queuing happens at routers, this can be a problem. Okay, that is, the packets which need to be transmitted within a given time, they become useless. All right. Now, of course, as we know, useless packets are of, why should I store useless packets? Okay, so you basically drop them. Okay. So what happens when we have queue in the routers? One, that packets may get dropped. Another, so that is due to the lifetime that has been reached. One reason. Another is what? That of course you will say that, okay, if I don't have any such constraint of time, then what will happen? Then it's good, your packet can stay in the buffer. But the buffer is a hardware, right? It is a physical entity, and therefore it will not be like an infinite buffer size. It is having a limited buffer size. So when the buffer becomes full, then of course whatever packet comes, there is no space to keep, so the packets will get dropped. Okay, so these are the problems that happens when there is a queue in the router. I hope this is clear. If this is not clear, please raise questions. All right. All right. So now I'm going to switch to the next kind of switching technique. Okay.
Ma'am,
So yes,
is that possible that the memory inside the router is full and the queue is still not moving so quickly? So how does the router deals with such situations?
so if the queue is full, then the incoming packets will be dropped, na?
Then like how that okay then the device chooses other router as for its transmission of data. Is that so?
What do you mean by the device? All our devices, no? Router,
Yeah,
source, destination.
like for example, my laptop is connected to a single router, and that router doesn't have any other connection, so it is like a unique path. And now my transmission rate is very high that router become full like instantly,
The
and
buffer becomes full. Yes.
then I can't stop, like the system is not stopping the transmission. Then what does the router does?
The router will simply drop your packets. Okay. And there are many ways in which, see, if your system finds out that, whatever packets you are sending is getting dropped, the system will stop after some time. So there are protocols made accordingly. Or the router will inform your system that, you are flooding me with so many packets, please stop sending. Okay, in any case, if the buffer is full and you are still receiving packets, the router still receives packets, then those packets will be dropped. Okay,
Okay, ma'am.
all right. So, next topic that we are going to study is circuit switching. So, circuit switching is an alternative to packet switching technique. All right. Now, you can ask me, why should I require such alternative packet switching? I mean, alternative technique to packet switching. Okay. So for that, we need to know that what are the disadvantages of packet switching, right? So can anyone tell me what can be the disadvantages of packet switching? For that matter, what are the advantages of packet switching? What are the disadvantages of packet switching? Can you think of anything? Anyone?
Hello, ma'am.
Yes?
This is Vikram Damle. I think
Hello.
one of the disadvantages of packet switching could be that the packets are arrive out of order if they take different routes.
Exactly. Okay, great. This is a good answer. That, if you are sending chunks of packets over the medium and they are independent packets, so in that case, the way they are being received at the receiver, that can be out of order. Okay, so once you receive at the receiver, the task of the receiver then becomes that, you have to sequence the packets. Okay, that is an actual issue that happens in packet switching. All right. Anything else?
That sometimes the data packets can be lost if there is a lot of traffic.
Yes. Good. What's your name?
Hardik Suhag.
Karthik. Okay. So Karthik has made a very good point that if there are so many uh, connections that are made with a router, so and if they are all sending a large amount of data, then what will happen is that after some time, they are basically sharing the same resource, right? So they will contend with each other, and that will create again issues with packet loss. It will lead to packet loss. Okay. So, circuit switching is kind of an alternative to this issue. Okay, both the issues that were told. Okay, so what happens in circuit switching? So it was told that, okay, why should I share the resources? Let us make it more secure and let us make it dedicated. Okay, so if there is this source and there is this destination which have been connected with a red mark. So if there's a source and a destination, before the transmission happens from the source to the destination, you just mention or you just reserve the path between the source and the destination. So the entire resource is being reserved for the entire duration of transmission. so that all the data from the source can be sent directly to the destination without being without facing any contention from any other uh, connected host. Okay. Okay. So, all right. This is a diagram that has been, so this is just the explanation of this diagram. I think you can read it up when I give you the PPTs. All right. So, okay. Now, let's check that why is circuit switching helpful for us. Okay. So, first thing is you can say that, it is not sharing any resources with anybody. So, you are getting the full resource. So, your capacity will increase in the end, right? Also, it will give you guaranteed performance. Okay, that is so since it is a dedicated path, okay, and the performance is guaranteed, that is why it is known as a circuit like performance. That means you are creating a dedicated path from a source to the destination, and you are ensuring or guaranteeing that the data that you are transmitting from the source will actually reach the destination, unlike packet switching where there is no guarantee for delivery of packets. Okay, because you don't know what's happening in between the routers. Okay, so you cannot guarantee that your packet will actually reach the destination. But here, since you have a dedicated path, you can guarantee that your data will reach from the source to the destination. All right. Now, what's the problem with this? This could be the best thing that could have happened over the history, right? But the problem is that once suppose circuit switching is somewhat like telephone networks. Okay, early telephone networks. So telephone networks, what happens when you have a telephone network? Okay, uh, your I'm talking about the landline phone networks. Okay, so what happens that you pick up the phone, you call somebody, and then this information that there is a call that is being that call request goes to the central office, and the central office used to create a line, dedicated line to the destination house, to the destination number. Okay, if you have seen very early movies, maybe you could see that they would show that if there is a call that has been made. In fact, not only in movies, if you ask your parents, maybe earlier times when you had to make a STD call or an ISD call, what you had to do is you had to call the telephone exchange, okay, the central office. And there, once you call them and inform them that this is the number I want to call to, and this is how much time I will take. That will be told by the office itself that you can take only this much time call or something. So they will make a dedicated line after that from you to the particular destination. So that is like a circuit, right? That is a dedicated line that is now created between you and your destination, and then you can talk with each other. Okay. Now, suppose this kind of a communication is going on that you were connected dedicatedly with some destination and you started talking, but something happened in your house and your telephone line got disconnected in between. Okay, but you were told that okay, the connection will remain for suppose let us assume it will remain for some 5 minutes of time. Okay, but the disconnection happened at 3 minutes of time. So for this entire 2 minutes, your uh, connection is there, the circuit has been made, but nobody is talking, right? Because the call got disconnected, right? So this is again a what do you call it? Misuse of the resources, right? The resources just idle. It could have been given to somebody else, but because it was already given out and for a given amount of time, and the call got dropped, so this resource is now idle. Okay, it is not being used anymore. So that is one of the disadvantages of circuit switching. Okay, that good that you are not sharing, you are getting a dedicated resource, but Not sharing is always not good, right? So this is an example of that. Okay, so it was also thought that okay, how do we try to share something in circuit switching also? Okay, so as you know, you have some idea about what is frequency division multiplexing and what is time division multiplexing. So here I'll give you an example here. So in circuit switching, these two concepts were proposed. Okay, that is the use of frequency division multiplexing and the use of time division multiplexing. Okay, so what happens in frequency division multiplexing? That you divide the entire frequency, okay, the frequency over which you will transmit the data. You divide the entire frequency into smaller, I mean, into different. So what happens is you are dividing the entire frequency to different frequencies. The um, basic concept is like that, but actually what is happening is that the different users are sending their data over different frequencies, okay, in the channel. So suppose there are 4 users, okay, so each of these users, so now just look at this one. So you are having this entire channel, they are at different frequencies, and you can ask your users to transmit at different frequencies, okay. So what happens, you your user is not sharing also, I mean not sharing the same frequency. They are having their own dedicated channel over which they can transmit their data by just doing FDM. Okay, so yeah, just look at this one. So all these users, so these are 4 different users given by different colors. So they are basically transmitting over these different frequencies. Okay, but what's the problem with this? In another in packet switching, what could have happened is you could have got this entire channel, the with all the 4 bands, right? The entire channel you could have got for one user, okay, if he was transmitting. But because you are dividing here into different small frequencies in FDM, therefore all the users are not getting the entire channel, so their capacity will decrease at the end. Okay. So how do we avoid this? So there was another method, that is time division multiplexing. So what do you tell the users? That okay, if you want more capacity, what you can do is just use this resource turn by turn, right? So what do? You just divide the time with time in which the users will access the channel. Okay. So what you can do, you can just allocate periodic slots to the users and say that okay, you will transmit in this particular slot, only in this particular slot. So in that case, every user gets a wider frequency band, and for its entire time slot, and the capacity also increases. Okay, so you can see here. All right. Okay. All right. So let's just think about the differences between packet switching and circuit switching. Okay, so what are the good points of packet switching? What are the good points of circuit switching? And what are the bad points of both? Okay, which one is better than the other one? So we are going to do that here. So suppose you have this system. Okay, you have n users, and it is a 1 Gbps link. Okay, so these blue arrows just show that data from these user is going out. Okay, it does not show that it is an open link. Okay, this is just one link of 1 Gbps capacity. Okay, so and there are n users connected. All right. So at a time, can anyone tell me how many users can use this network? If you can just think of it. If I use packet switching or if I use circuit switching, which one should be better? Which one will provide more number of users to use this link? Any thoughts?
Hello, ma'am.
Yes,
This is just a guess, but would circuit switching be better? TDM, sorry.
TDM.
Bec-
Okay, why you are saying that?
because each user is active for only a partial amount of time. And so that was one of the reasons. Otherwise, maybe you could use frequency division because they're only using 1/10 of the bandwidth of the link.
Hmm. Okay, TDM is, acha, you are saying either TDM or FDM, but
Yeah,
circuit
either. Yeah.
is. Okay, all right.
So
So
both
you
of
are,
those work in this situation.
huh,
But yeah.
it will work. I'm just asking that you are basically saying that packet switch rather than packet switching, you would go for circuit switching, right?
Yes, ma'am.
Yes. Anybody for packet switching?
Ma'am, one more point to add, like if there are more than let's say 10 users, then each user will be active for 10%, and if we completely dedicate the whole circuit like using TDM, then he will just use 100 Mbps, but we have 1 Gbps. So like for each slot we can again divide that slot for the bandwidth of the slot for 10 users. So it's like using 100, and everything will be efficient also, like everyone met with their requirements, like 10% of time will be given and 100 mbps is also given.
Hmm.
So
Okay,
maybe it's like hybrid of both tdm and fdm.
hybrid of both TDM and FDM. Okay. Uh, all right. Now let me give you just an example. Suppose one of your users or two, three of your users are just uh, transferring or basically uploading movies. Okay, and each movie is around 2 GB or 1 GB or 2 GB kind of data. Okay, so in that case, if you are using your technique, they will face delay, right? Quite a lot of delay, isn't it?
But in the requisite we are given that they will use up to 100 mbps when active. So
Oh, you are looking at this one. Okay, I just gave a question out of my mind. Okay, I did not give anything from the example here. Okay, let me look at the example. So they are saying that it's a 1 Gbps link, 100 Mbps when active as 10% of time. Okay, in that case, you are saying that you will be using circuit switching. Okay, all right. So nobody for packet switching, only circuit switching will be great. Is anybody against circuit switching in the class, or everybody agrees to what they have said? All right. So I am not getting any answer. So I'll just tell that I will go for packet switching. Okay. Why? Because suppose there are n users. All right. Now I know they will be active only for 10% of time. But if I'm using TDM, okay, the moment I get my time slot, I may not be active. Okay. But I can have some data in between the time. All right, in between the slots that was given to me, I can have some amount of data that got generated. So I have to wait until my slot comes again. So that will be the delay that will be added, right? So I don't want delay also, right? If I am a user, I do not want any delay in my communication. I would want to lower it as much as possible. So that is one problem. Now if I'm using FDM, then what will happen? That as I gave you the example, that if suppose I have a very large chunk of data, okay, so I am just sending it over the channel, but the capacity is very less, okay, even though I am using FDM. All right. So in this case, what would happen is that the capacity that will be received at the receiver's end will be very less. Okay. So I am not saying that always packet switching is better than circuit switching, but in this case, I am just giving you an opposite direction. That what if I use packet switching rather than circuit switching? Okay. So it always seems that packet switching, because it is sending out independent chunks of data, it is not creating a dedicated link, and there is no misuse of resources. You are trying to use the resource as much as possible. That is why some people will say that yeah, I will choose packet switching over circuit switching in this kind of a network. Okay. So if I say so, is packet switching always going to be better? That exactly is not the case. Okay. So where is packet switching good? Okay. And where is circuit switching good? That is what we need to find out. Okay. Packet switching will be good for scenarios where you will have sudden bursts of large amount of data. That is known as bursty data. That means sometimes the data is less, the data that is arriving. Sometimes it is very high. Okay, so that is known as bursty data. Okay, so why it becomes helpful? Because when it is bursty data, in that case, what would happen is you don't know that how much of data is going to come. Okay, so it is best at that time to have these independent packets being sent over the network. Okay, so it is better to have resource sharing. And of course, for every, so if you have a burst of data coming to you, it will be difficult for you to set up the entire circuit for transmission, and then start the transmission again. It looks very easy that once there is a request, the entire circuit will be set up and then data will be transmitted, but it's a long process. Okay, we have to request for the connection, then it has to be approved, then again there will be this connection made. Once the connection is made, then the acknowledgement will come, and then after that only the transmission can happen. Okay, so that's a long process to set up the circuit itself. So if you have a large burst of data coming in, you don't have time to do such things. Okay, so that is why it reduces the delay with no call setup. With no call setup phase, and therefore it becomes simpler to just whenever a packet is coming, if there is a place in the queue, you put it into the queue, and then if there is a chance to transmit, then you just transmit. Okay, the amount of complications reduces a lot. Okay. Now, what can happen in such bursty data cases? That there will be excessive congestion. Okay, that means too much of data is coming to a particular particular node or host, you can call it. So in that case, the entire queue will be congested with all the packets that are coming in. What will be the resultant of that? There will be packet delay, and of course there will be packet loss due to the overflow of the buffer. Okay, so what do we need for packet switching? So because congestion is possible in packet switching, what we can do is we have to find out different ways in which you can ensure that you can ensure as much as possible that whatever data is being transmitted, it is being received at the receiver's end. Okay, some amount of guarantee of data transfer. Okay, you cannot guarantee in packet switching, but you can try. So this, for that we need several protocols for having reliable data transfer and for doing congestion control. So someone just asked me few slides back that what happens if there is a router and that is full and still the source is sending the data. Okay, so in at that time I told that packet will be dropped. Okay, so this scenario that the source is sending a large amount of data to the router and the router's buffer is full. Okay, so that condition will be known as congestion. Okay, so too many devices are sending, if there are even one device or even too many devices, if basically data is getting flooded to the router and it is its buffer is overflowing, then in that case it will known as congestion. But what is the task that we need to do? We need to have some kind of method or some protocols to control this congestion. Okay, so that's why I said that either the router will tell the source that you are flooding my buffer, or the source will just see that whatever it is sending, that is not going to the destination. Okay, so there will be, so how will that be found out? With reliable data transfer. That means reliable data transfer will tell you that whether your data is actually getting received at the receiver's end or not. If you find out that it is not getting received at the receiver's end, then you will guess that okay, maybe there is a congestion. And how will the source control that congestion? By just stopping the flow of data. Okay, it will stop transmitting the data for some time. Okay, this is just an example I'm saying, that suppose it is just stop the transmission of data for some time. So these will be some types of congestion control, and when we are using packet switching, these are what we need to know. Okay. Hmm. All right. So this is a question that has been put, that how do we provide circuit-like behavior with packet switching? Because we will feel that even in a bursty environment, if we could have a circuit switch kind of an environment, then we could guarantee delivery of data more, right? We could guarantee the delivery of data. So giving circuit-like behavior to packet switches is very difficult. Okay, but we can try to have certain protocols which will help us to give better performance. Okay, it will try to enhance the performance than what packet switching is giving us. All right. So I will end the class here today, but before I end the class, I would like to ask you one question. You can give me the answer in the next class. What do you think is used over the internet? Is it packet switching or is it circuit switching? Whatever you choose, you can give me your justification for that. Okay. So please check it out or think about it. Which one should be used over the internet? Packet switching or circuit switching? Okay. So, and with this, I will end the class. If you have any questions, you can ask me. Otherwise, class is over. Thank you.
Hello, ma'am.